Right, so we go for module 4C, lubrication, and you've now read through the first 12 pages of the module. Now I want to go through the same material again with you. The idea not being that you have not done it properly, but just to highlight certain things. For that purpose, what I've done in the presentation is again, some of the slides have stars on it. I'm afraid it's most of the slides in this case. And those with the stars on it, we will spend some time on. Okay, so let's start that. So we start by introducing the subject of lubrication. Let's just look at that. The definition of tribology. We said tribology is the science and technology of surfaces in relative motion. So whenever we have surfaces that moves relative to one another, over one another, then we talk of tribology. And tribology, if we then talk of the science, we talk of different things. We talk of the materials involved, we talk of the surfaces involved, the surface designs, we talk of the lubricants that we use between the surfaces, and so forth. So tribology is a fairly complex science on its own. And again, we're trying to do too much in one session, but at least we put forward some of the principles. So lubrication is just a part of the science of tribology. So let's look at the study areas of tribology. We say the study areas are friction, wear, and lubrication. So saying then that whenever we have surfaces in relative motion, we have friction. Friction is involved. And we then have wear. Wear takes place because of the friction of surfaces moving over one another. And then lubrication is the way in which we try and reduce the friction between components, between surfaces. Surface finishes. I thought to quickly just run over this as well. We have three types of surfaces here. We have a turned surface here. You can see the grooves caused by the tool going through there, cutting through there. And we have a shot blasted surface here. And we have a ground surface. And a ground surface there. And what we say here is we say that ground surface and turn surfaces are directional. So we can see directional lines across it. Whereas with a shot blasted surface, there is no directionality. And of course that has an impact in the whole study of the movement of surfaces over one another. The contact between surfaces mainly occurs on the higher areas, or what we call the asperities of the surfaces, which is like little buttons or little protuberances that protrude from the surfaces. If we go back to this, we can see the different little things that sits on here on the turned surface, even more so, and so forth. The asperities are revealed by a study of the surface profiles. In other words, if you go and look at it microscopically, and small, you can prove it to be blunt, with very few of them having slopes higher than 10%. So it's convenient to model these asperities as perfectly smooth and spherical, or conical, or pyramidal in shape. Now, that's maybe just for theory's sake. It's maybe not that important, but it's important to take note of it. And then we can do different things. We can calculate different things, and I don't intend to go into that. But what is maybe important here is that one can calculate from Hertz's work, which we've talked about here on the previous slide, to calculate if you have an asperity pressing against the surface, you can calculate that surface area which makes contact with one another. and also the profile, the tension profile that develops here, the pressure profile. In terms of friction, we say you have two types of relative motion, the sliding and rolling. And we say that in both cases, one have a sliding action. Even in rolling, in pure rolling, you have a sliding action. The reason for that being that you can't get a grip between the rolling element and the surface. You cannot develop a grip without some sliding. In other words, there must be some slip, because you develop your power between the two surfaces. You develop through the slip that takes place there. So we look at the laws of friction. There's three laws of friction. The first law is that the friction force is proportional to the normal load. That just says that the load that works down on the body, that slides on the surface, that load, the friction is proportional to that. So there's some constant type times the friction gives you that force. And the second law says that the friction force is independent of the apparent area of contact. What does that say? It says that the contact area that we think, the apparent area of contact, the friction force is independent of that. And I'll come back on them just now, because I want us to think about an example. The third law says that the friction force is independent of the sliding velocity. In other words, it doesn't matter how fast it slides, the friction force remains the same. There's no relationship there. Now, those three laws of friction has been postulated very, very long ago. And